Okay, I'm back in part two to talk about this whole continuous distribution. And so previously, in a previous video, we set up this problem. We knew that the mean wait time was 12 minutes, and we found the probability of the wait time being less than 14 minutes, right? So I'm just going to illustrate this a little bit. So with this being a continuous probability distribution, we know that when we're finding continuous probability distribution, we're finding the probability of everything under the curve, right? So the probability of x being less than 14 is everything that's calculated under the curve. But what if we were asked, and I'm going to change the color of my pen, what if we were asked to find the probability of x being greater than 14? It can't be equal to, greater than 14. If we were asked to find the probability of x being greater than 14, right? How would we find that? So in order to do that, we found the probability, when we solve these problems, we're always looking at what is under the curve. But in order to find the probability of x being greater than 14, is the complement of x being less than or equal to 14. So this probability is going to be equal to the probability of x being greater than 14 is equal to 1, it's a complement, 1 minus the probability of x being less than or equal to 14. It's the opposite. So in this particular situation, we have found the probability of x being less than or equal to 14. Here, it is the 0.7486. So this would be equal to 1 minus 0.7486, right? And that gives us 0.2514 because it is the complement and the opposite. I hope this is helpful. It's very important moving forward. And then I have one more trick to show you. So I'll be back in one additional video to show you just a couple other things, a couple other nuances of working with normal distribution. And then we'll do a refresher on the empirical rule.